Hi, everyone. Today we're going to look at naming molecular compounds. So this is something that, again, you guys did quite a bit in grade 10. Um, for molecular compounds, it involves two nonmetals. Okay, so it's a nonmetal plus another nonmetal. And all of your nonmetals are actually found on the right-hand side of the staircase on your periodic table. So there is actually one nonmetal that's found on the right side, and that's hydrogen. It's only on the right side because it does have properties that are similar to metals, but for the most part, it is a nonmetal. Okay, so when we do something like this, a nonmetal plus a nonmetal, it could be as easy as H and O. Okay, so like we said, H is a nonmetal because it's mostly a gas at room temperature, and oxygen is also a gas at room temperature. So they're both not metals. So one very familiar nonmetal compound that you would recognize would be having two H's and one oxygen. So of course this is water. Okay, water is a common name that we give to some of these molecular compounds, but some compounds don't have common names, and if we have to name them, we actually have to use prefixes. So for this particular lesson here, I have the list of prefixes listed on the side. You can also find this section in your notes package that I gave you at this point. So if we were to rename water as a scientific or a chemical name, it wouldn't be H2O water, it would be dihydrogen monoxide. Okay. Prefixes are words that come at the beginning of a word. Okay, so because we have two hydrogens, we use the prefix of di, and because there's only one oxygen, we use the prefix mono. Okay, so because oxide begins with an O, okay, we only use mono in terms of one O, like MONO, and then oxide. Okay, we don't have an extra O between the N and the O. Okay, because that would just be pronounced a little bit differently. But this is just the basics of naming with molecular compounds. So I'll have this list handy when we need it. I'll give you a couple of other examples. Okay, so the ones that I have here, these three, CCl4. Let's start with that one first. So anytime we have an element by itself, in this case carbon, okay, we don't always have to use the word mono in front. You can, it won't be wrong if you did, but usually if there's only one element at the beginning, it's okay for us to just use the name of that element. So in this case, we'll just use the name carbon. But we have to clarify what the 4 is. The 4 means that you have 4 chlorines. So what's the prefix for 4? Well, it's tetra. So it'll be carbon space tetrachloride. So Cl is chlorine. We drop the INE ending and replace it with IDE. So it's an IED ending, so it'll be chloride. The tetra refers to the 4. So tetrachloride just means you have 4 chlorines. Okay, so carbon tetrachloride means you have 1 carbon, 4 chlorines. That's all it is. So if you look at P3H8, 3, the prefix for 3 is tri, so this is tri. P is phosphorus, so it's triphosphorus. Okay, 8 is octa, so it'll be triphosphorus octa. Oops. H is hydrogen, but we don't use the full name hydrogen. We just use the root name, so we use hydro. and then drop the ending and put in "ide." So hydrogen becomes hydride. So this will be octahydride. Okay. The last one, again, you have two sulfurs. Okay, so the prefix for two is di, so that's what you start with. It'll be disulfur. So full name of that first element. O is oxygen. There's 5 of them. The prefix for 5 is penta, so this will be penta, and then oxygen becomes oxide, so you just go pentaoxide. Okay, so using prefixes is very easy. I actually find this to be easier than the ionic compound naming. Okay, just keep in mind that nowhere in this type of naming will you ever use Roman numerals. Okay, so let's look at doing the reverse. So if I give you a substance called dicarbon hexafluoride, okay, you have to figure out what that means, right? You have to figure out the formula. So carbon is the easiest one to identify because it's just a C. We saw it before. Di means 2, so it'll be C2. Fluoride sounds a lot like fluorine, okay, and the symbol for fluorine is F. Hexa means that you have 6, so it'll be C2F6 as the chemical formula. Dihydrogen dioxide is the next one. So again, di means 2, and since you have hydrogen, it'll be H2. Oxide is oxygen, and again, there's a di in front, so it'll be H2O2. Okay? That's the chemical formula, and this is the what we call the binary name for this substance. H2O2 also has a common name as well. And I don't know if you know what it is. Okay, I'm sure that once I say it, you probably would have heard of it. But H2O2 as a common name is called hydrogen peroxide. Okay. It's nothing that I expect you to know right away, right now. But as you progress through chemistry, there will be a lot of common molecules that we don't necessarily use this naming system to name. We sometimes would just give it a common name because it's a lot easier. So in a nutshell, again, this is basically molecular compounds and naming and writing molecular formulas.